Stevan Little. Some of you may know some of my work. I was the original author of the Moose module and a bunch of other stuff on CPAN. I'm going to talk today about my most recent CPAN contribution, which will get uploaded. I thought I'd have Wi-Fi here to upload it, and I was wrong. So when I get back to the hotel tonight, if I'm not too drunk, actually if I am too drunk, who cares? Just CPAN. I'll upload it. But anyway, I just finished the docs, so that's good enough. But anyway, so before we go too deep into this, I decided to take a little look back to sort of see the history of debugging on the web. And I'm just going to qualify this as, this is not necessarily a comprehensive history, that'd be its own 50-minute talk. It's basically all the stuff that I encountered over the years. And I thought sort of I'm trying to represent a sort of an interesting transition that I think happened. So 1996, I don't know how many of you found yourself doing this in Notepad, writing up your little CGI bin script. This was the state-of-the-art debugging tool then. It's not really that much different nowadays. And of course, unless we were a Unix geek, we grabbed our WSFTP Lite Edition, because nobody paid for software, drop it in the CGI bin, refresh our copy of Netscape Navigator Gold, see whether we fucked up or not, and of course then log into a server and tail logs. That's how we should think about it. Or Telnet, Telnet, maybe there's Telnet, maybe there's SSH. Everybody had their own way. So that was sort of the early days, the very early days. In about 1999, I actually started doing a lot of work with some classic ASP. How many people here have had the pleasure of classic ASP in their lives? Not many. That's good. That's good. We can commiserate at the bar there. And the state-of-the-art debugging tool for that was essentially this. Okay, so your response writing, and of course this is going out in the stream of your HTML page. So if you were good, you'd throw it inside comments. Okay, so again, you see the advances here. And of course, if you were writing in VBScript, you could use this debugging tool, which basically said, I don't care, just threw them all out. And then of course, if you've done any of this stuff, you open up your Internet Information Server Manager, you can make your website, you configure it all with these things, because who needs configuration files or anything like that? And then woohoo, you're running and off and running and it doesn't run. So that was 99, things got a little bit better, not so great. 2001, I was doing, so my previous job I was a consultant, so I managed to touch and see a lot of different technologies and a lot of different horrors in various places. In about 2001, I started seeing a lot of Java. And I also saw a lot of really cool tools that would like connect, your server to your debugger and your IDE and all this crazy kind of stuff like that. But the reality is, I also saw a lot of this, and some of the Java code that we were consulting on, which really doesn't seem like it's that much of an improvement. Also, 2001 was PHP with this state-of-the-art debugging tool. And of course, those are both Unix technologies. So again, we had to telnet into our server and tail our logs. And really, it was 2001. I mean, like, couldn't we had our flying cars, we had all that stuff like that, we had space travel, why couldn't we have good debuggers? 2003, I'm jumping ahead here, so the company that I was working for, we did a lot of classic ASP consulting for a while, that went away for a while, we started doing a lot more Perl, stuff like that, but then in 2003, you got your ASP.NET, and some of our old clients wanted to upgrade. So if you've ever programmed in Visual Studio, you might know all this stuff. I think this is code down here, but I don't think it was written. I think it was generated. But you'd think, okay, wow, cool. This is 2003. We've got more cool stuff. And I thought initially when I went and started doing some ASP.NET, wow, okay, I'll just use what I know, which is writing out to standard error. The problem I had with that was I couldn't actually find out where it was writing to. I know it was a file somewhere on the server, but the guy who happened to be sitting next to me said, no, that's the wrong way to do it. This is how you want to do it. And I was like, why the hell do I want to throw an exception? That doesn't make any sense. And then he showed me this. And you can't really see it very well because it's a little washed out. But it would dump to your browser. Okay, which brings me back to the fond old days of carps fatal to browser, or CGI carp fatals to browser, which wasn't quite as featureful as this. But still, I didn't have to leave my browser. I didn't have to go digging through a log file like some fucking animal or something. Then in 2005, Ruby on Rails revolutionized web programming for Java devs. The rest just already knew what they were doing. And truth be told, I've not done much Ruby on Rails programming, so I decided, well, let me see what I can find with Google. And I found this. It was deep inside some sort of Rails plugin, but I thought it was just very interesting. What's going on here is they're actually doing the module eval basically gives you a context to eval something in. They're pulling out the old raise method, which is the function to throw exceptions. Okay, and that's found inside the kernel object in the Ruby object system or object hierarchy. They remove it and then they redefine it. And basically, all this is doing is I think it's there's some sort of carp extension where you can basically say, okay, carp, ignore these modules in your backtrace. Okay, and that's pretty useful when you have, you know, a layer of stuff on there. And that's actually what they're doing here. They're just doing it in an extremely evil monkey patching way into the core of the language. You may look at that and say, well, it's ugly, that's crazy, monkey patching, who wants to do that? But the fact of the matter is it allowed Rails, and this is actually a newer Rails UI, I couldn't find an old screenshot, but allowed Rails to give much more featureful error messages and error reporting screens. So you have things like the application trace, the framework trace, the full trace. So being able to filter and look at the stack in your trace, not just having to go through the console log, stuff like that. And so this was sort of, it was a trend towards, you know, in your development mode, getting more information to you and getting it not just as a blob or a wall of text. In 2006, somebody came up with the great idea to mix PHP and JavaScript together in your browser. Go on from there. We'll even talk about it. There's a reason why that bug is on fire. Then in 2008, the Django folks, the Python guys, okay, or Python guys and girls, they added a sort of feature to the Django framework to do these debug panels. And the interesting thing about this screenshot, and the point that I really want to make here, is you saw, you know, it got more and more, it was starting there's more and more software there to capture your errors and give you good, useful stuff. There's no error on this page. This is just information, okay? So the Django guy said, well, you just need to know what's going on in the system. Before something even goes wrong, you might want to spot something that maybe isn't wrong enough to throw an error. So they have this, and they have a lot of really interesting panels that they put out for it. So, in 2009, one of the most prolific polyglots in the core community, Miyagawa, assimilated something that I've decided to call a yappy, which is yet another Python. Okay? So Larry stole the object system, but Miyagawa said, hey, they've got this great thing, WSGI. Why don't I make a PSGI, which is a Perl Server Gateway Interface? Okay? How many of you are familiar with PSGI? Good. We were talking on PSGI like maybe 3 or 4 years ago, and like there was like Miyagawas in the back. You know? PSGI is really cool. The server end of it's really great. All that kind of stuff like that. But honestly, what I always found more interesting about it was middleware. Okay, the concept of PSGI middleware that you could wrap around your application and provide additional functionality there. Now, what does that have to do with debugging? Well, later in 2009, only a couple months after Miyagawa actually put one of the first releases out, Marcel Gruner, and I'm probably screwing up his name, he basically took yet another Python idea. And hey, doesn't this look familiar? Okay, so he took this and he made the Plack Middleware Debug module. How many of you have used this module? Okay, good amount, good. Okay, so that concludes our history lesson. Here we are now in the future, 2014. So recently I actually joined Booking.com, moved from the States to the Netherlands. And in case you don't know, we are hiring. And if sex and drugs don't entice you, maybe Dutch breakfasts will. They do eat this, right? Right?
Mm-hmm.
Yeah. Okay.
Well, the blue stuff only when you're in the UK.
Okay, yeah, blue stuff for the babies.
And it's a better photo than Stampot.
So anyway, so one of the cool things about Booking that I like is that they're very big on internal training. So within sort of the first couple of weeks there, I was feeling a little overwhelmed and everything like that, and there was a Plack training, and I thought, shit, I know this stuff, I'll just go hang out for half a day. So the training was given by this guy, the short one, not the tall one there. This is Sawyer X. He's the dancer guy, but he's also, in booking, he's one of the Plack experts. So he gave a talk, and one of the things he talked about was just sort of the Plack in general, which I was able to nap through that part. But he went into sort of the way our stack is engineered at booking. And I don't think that I'm going to require everybody to sign an NDA, but I'm pretty sure this is public information. So basically our stack works like this. We have NGINX on the bottom. We have a thing called micro WSGI, which is also a great Python idea. If you're not familiar with micro WSGI, I suggest you Google it. The U, just change that micro symbol to a U and you'll find it. And all it really is it's sort of like fast CGI, not written in 1999. Okay, so it's done really smartly. It gets a lot of some process manager stuff like that, and you basically get an embedded Perl interpreter that you can run within this space, and it's a lot of really cool stuff. On top of that, we have Plack. Plack is kind of mixed, and is really a lot of what the Plack layer does is actually provide an Apache compat layer, because booking used to be written on mono Perl. So one of the cool things about Plack was that we were actually able to pretty much emulate most of the non-Perl APIs, at least the ones that we were using, but still provide it. And then, of course, on top of that is all the booking-specific code.
Including the crazy ones.
Include what?
Including the crazy ones.
Then, in the middle of all that, on all of our dev KVMs, is Plack Middleware Debugger. And it's actually, by default, enabled on those various, or on those dev machines. So one of the first things that I got to do when or one of the first groups that they put me in when I got a booking was a team called Intranet Reliability. And the mandate for the team was to go out and improve things. Kill some warnings and errors that might be happening somewhere that nobody's getting to, or improve tools or something like that. So I did a few things here and there, dove in some old code, Mason code, this and that. And then I saw something on the backlog that they wanted to add AJAX support to the Plack Middleware Debugger. Now, there is actually a plugin out there to do this. And when I looked at that, I thought, oh, cool, my job's done. It wasn't. Because the fact is, we don't really use Plack Middleware Debugger, or we didn't use Plack Middleware Debugger. We used Plack Middleware Debugger++. And it was just all this weird stuff that we did in order to make it work with our stack. So I spent some time digging into that. And basically, after looking at that horror, I decided it was time to rewrite. And it wasn't just a knee-jerk rewrite. There were certain design considerations that the old system did, or the old module did that we needed, or the old middleware did that, or didn't do that we needed to have, and things like that. So we decided it was a sensible thing to do. So one of the things I did first was gather some goals, figure out like, okay, I'm going to rewrite this module that everybody uses. Let's see what I can, what can I make smart out of this. And in particular too, booking was paying me, so I needed to do what booking wanted. At booking, we have sort of a fetish for monitoring things. Okay, we monitor our users and how our code affects our users. We monitor how our code affects our hardware, our software, the relative height of the mohawks of our programmers. Okay, and in Nick's defense, this is his business mohawk. He probably had a meeting, but when it stands up, it's higher. So, but the thing is that all the booking, we have these monitors around that you can see. How you can check server health just by looking up, because we have what do we call them?
Sorry?
What are the names for all the monitors around? Somebody gave them a good name.
I don't know what they called it. I just call them monitors.
It's got graphs, and it's what the traffic is, and this and that. So we're a very information-hungry culture. So I thought to myself,
he's not kidding when he says we measure everything.
Yeah, everything. Okay. So I thought to myself, all right, I need to make sure that what I'm going to do is going to be able to pull as much information in from as many different places as possible and be able to display it in as many different ways and all that kind of stuff like that. Then I went around too and I asked people, hey, you've been using the debug panels. What would be your #1 feature request? I asked all around, and this was actually the number one. There was a couple people who liked it, and a couple people who really used it. And actually, when I broke it later on, those people came and found me. but most of the other people, people like to complain. It's just the way it is. But so, in summary, I decided that the goals that I had, or the goals that I needed, were to provide the most visibility. So the most visibility into what's going on during the space of that web request and any other ones, with the least intrusion. Okay, so all those people who were complaining, how do I disable it? Well, probably because it was getting in their way. They had other things to do. Maybe they were a front-end dev, so they didn't really care what went on in the server. They just wanted to look in their JavaScript console and this stupid Plack thing. So the idea was I got to figure out a way to make this the least intrusive as possible, but while giving the most information and being the most flexible. Because again, I don't know, Eve mentioned earlier in his talk about Serial, we have a lot of different server roles, which is basically a persona for a particular set of boxes. And not all of them have, some of them are dealing specifically with, credit cards or something like that, PSGI stuff. Other ones are just, your standard looking at the hotel pages, things like that. So it was important that the debug panels be very flexible so that we're not basically giving people information that they don't really need in that particular thing. And then most importantly, we have about 600 devs, probably more than that now, I don't know. And if you guys have talked to the recruiter, maybe even more. But I had to make it useful for all those people. I had to not screw up their workflows, things like that. So I'm going to quickly go over the design, and then I'm going to dive into some actually live examples, so hopefully they won't screw up too bad. Just quickly, I'm going to review the old Plack middleware debug design. It was based heavily on middleware. And what happens is you configure your Plack middleware debug, and you basically tell it all the panels, the debug panels that you want it to run. So, and each one of those is actually written also as a piece of middleware. And so they just continually wrap and wrap and wrap middleware until they're wrapping around the app. And the idea is the request comes in at the top, goes through the main debugger, goes through all these different middlewares, they collect their information. On the way out, they do the same thing, and then when it comes on the way out, it writes in information into your request output stream, okay? Potentially a lot of HTML, too. Dump all the HTML. I've seen upwards of 1.5 megabytes of HTML just being injected with a regular expression with this module. And what it would do is it would be injected right after the bottom of the body tag. This actually, I forgot about this in the goals. One of the other complaints was the people who weren't just developing web stuff and web browsers were like, why is this stupid thing like screwing up my Android, or my tablet view or something like that? And it was because it was injecting all this HTML and totally fucking up their CSS. So that was one thing I knew I had to not do. So quickly, here's the design that I came up with. So I abandoned the whole idea of the middleware, the stack middleware, for the simple reason that it was a little difficult to tell the different phases, like when am I actually in the before phase of this request, when I'm in the after phase of this request. There's also a little known cleanup phase that is part of the PSGI spec. It's actually an extension to the spec. So there was no clear distinction as to when those phases were happening. So I decided, all right, the panels have to know how to do that. So instead of just wrapping everything in middleware, I'll have explicit begin, or before, after, and cleanup phases that you can specify in your debug panels. Because I didn't want to inject 1.5 megabytes or more of HTML, I thought, okay, we're going to pull this in with AJAX. So I need to be able to store the results of the debugging data somewhere, so that's where the storage engine comes in. So that right there just sits there. It's actually not connected to Plack. It's not connected to your web application or anything. It does that instead through these other two things on the other side. The collector basically uses the debugger during the space of a request to collect data. And it saves it. That's it. It's all it does. It has no other responsibilities whatsoever. Okay? So it's just writing data, writing data, writing data. So you don't even have to have the front-end UI of this to be collecting data from all the requests that are going on. You just enable the collector part of it, and you're done. The other part was the injector, which is a little faded out there, but the yellow blob there. The injector is the thing that actually put the no longer 1.5 megabytes, but instead just a single script tag into the end of your request. Now, one of the problems with the old Plack middleware debugger was that it would basically only inject for text/HTML or application/XHTML. Those are the only content types it would inject anything for. Also, the only content types it would actually collect data for. Okay, so it not only did it inject all this junk into there, but it was very inflexible about when it would actually run and do stuff. So the injector actually checks status codes, it checks certain headers, and it checks content types, all of which are overridable in a subclass if you happen to not like my decisions that I made. But the injector will do that before it actually tries to inject that content into your request. So it tries to be very good and very well behaved about when it injects this stuff. But at the same time, because it's decoupled from the collector, all your information is actually still being collected. So you can still go back and read that data if you want through some other way. Now, because we're storing data here, we're collecting it there, we're injecting a little bit of JavaScript here, all this has to, and that's the power of the JavaScript UI, it's got to somehow communicate back with the server. And that's where the HTTP API is. And all that really does is it just serves those JSON files that have been collected. So the key idea here, though, was to break these things up and get a proper division of responsibility, but also have the ability to use some of these pieces in context, or in different contexts. So some examples. So the quickest, simplest panel. There's a lot of boilerplate here, I know. I've not yet tried to sort of get rid of the boilerplate and put some sensible defaults in there, simply for the fact that I didn't know what the sensible defaults were. And it's very easy to subclass each and every one of these modules. They all have a very well-behaved constructor, so you can simply subclass, pass in the arguments that make sense to you, call the constructor, and be done with it. You've got a simple subclass with one overridden method, which is the constructor. So, so bear with a bit of the boilerplate. So first here is the debugger. All right. The sort of key part here is the storage engine. We need to pass in a directory where to put it. We typically do this at work, just dump it there, because it's temporary data anyway, it's going to go away. You also need a serializer and deserializer. Not everybody likes JSON. JSON is easy for me to use in testing and stuff like that, but we use serial for the actual work version of this. So the ability to sort of do that if you want. And then a file name format. This is the files that are going to be written to that temp directory. This actually does have a default, which is just %s. It just passes it through. And what it's actually getting passed is what I call the UID. It's not the UUID, because I don't care whether it's universally unique or not. It's all just running on your one development machine, so just plain old unique is fine. But if you wanted to make something a UUID, it's just as simple as that. Tell the debugger, okay, here's the thing to generate the page IDs for you. And then the last thing is panels. So you just put in a bunch of panels that you want to have run. So that's just the debugger. Again, that hasn't connected to any sort of Perl process or Plack process or anything like that. The next thing you do is you have to create that web API I was talking about. So this is Plack App Debugger, and it just needs to copy the debugger. And then you put this all in and mix it in with your Plack. So here you see it at the top, /debugger, and we call the to app on our web API. That /debugger is the default. It doesn't have to be the default. You can change it if you want. All you actually have to do is specify a base URL in there, and everything else will sort of fall into place. The next thing is, then within your application itself, you want to enable the injector. So you'll see that the Debugger app, which was our web API, creates the middleware for the injector for you. That's because the two of them are two sides of a communication line. You have the injector just sent the JavaScript over the wire. That JavaScript needs to know how to call back to get its information. So the two of them are reasonably tightly coupled. So one generates a middleware for the other. The next thing is the collector, which is reasonably tightly coupled with the debugger itself, because that's the thing that it uses to call the different phases of the different panels and save the things to storage and all that kind of stuff like that. So they're kind of a little coupled there. So, live demo time. Let's see how this works. Okay. All right. So that code that we had, this is it. All right. So the HTML, just hello London. That little hamburger in the corner there, that's our debugger. The escape key is bound the JavaScript to open that up. One of the first bugs that I got was the people who were in charge of like the photo carousels that also close with the escape key. They yelled at me because I took over their escape key and I also didn't bubble up the event to them. So all of a sudden all their shit broke. And they're like, why does the debugger keep opening on me? So this in and of itself is pretty darn boring. But you can see we've got elapsed time, start time, ending time. Very, very simple. And just to give you an idea, this is that module. Okay. So like I said, a lot of these things are set up to be well behaved so that you really just have to override the constructor. So it overrides the Plack Debugger panel, and it just provides all these arguments for it. So you've got a title, formatter, which I'll get into a little bit later. We've got the before event, so it runs before a request. Here it's just stashing the time of day with time high res. The after does a little bit more because it pulls out from the before, does the calculations, sets the result in there, also writes the elapsed time into the subtitle, so all this kind of stuff like that. And now none of this is actually affecting anything. It's just data purely. It's building metadata that's going to get saved in that temp directory we saw earlier. So that wasn't terribly interesting, but I think hopefully that gives you an idea of just the basics of the structure and how it goes. Sometimes, obviously, you're going to want to do more than one panel. So, a little bit more code here. Not too much interesting though, because really this is the meat of what I'm trying to show you here. You just add more and more panels. You could be conditional about adding these panels in. You could build and write separately. You can do whatever you want. In the booking code, we branch based on those server roles, those personas that I talked about before. We branch based on those and provide certain debug panels. So some debug panels work well for our front end guys. Other ones are more important for our back end guys. So we conditionally add those in. No changes here. And second demo time. Crap. Why is there a oh, there it is. And refresh. And you can see we have a lot more stuff now. Okay? And another thing, this popped out all of a sudden all on its own, and it's yellow. What the hell's going on here? So these actually, so that was all those debug panels in there. We've got a couple stuff in here. We've got the timer, which we saw before, not terribly interesting. We've got the Plack response. What this does is on the way out, it just grabs a Plack response and says, well, let me just take a look at it, figure out some stuff for you, and just display it for you. So you can see on the body, we tell you it's a string because it could also be a code ref, it could also be a file handle, all those kind of things like that. So we detect those and let you know. And then this thing up here, the success, you can, actually, let me just show you the code. We have a system, or a part of the system called notifications, okay? So it's a way for you to say as you're going through, okay, these little events happen. They're not worth giving you full information. I just want to let you know that this happened, that 5 warnings fired, or 2 errors happened, or whatever. So you can notify within the callbacks, and it just keeps account of those. And it's basically success, error, and warning. So you can see here, I look at the status code on the Plack response, and I decide whether it's an error or a success, and I just put the notification in there. And that gets us this little thing right here, but it also gets us this little badge over here. And this is not very exciting right now, but you'll see where it's more useful later on. We got the Plack request. We're pulling out all those keys in your standard Plack request. The Perl config, in case you were wondering in the middle of your request, well, what configuration parameters was my Perl compiled with? You can check. That's not that terribly useful in practice. Environment, this is useful in practice. What's going on? Why is it? Oh, look, that environment variables. Look, I've been doing Go programming. That's what's wrong. request parameters. This is one of our formatters to do nested data. Woohoo, fancy. You couldn't do that shit in 1996. Well, you could. You just have to refresh the page every single time when you did it. So this pulls out the query string. It'll also display the session, looking in the PSGIX .session key, which is the standard place for PSGI sessions to go, but not the enforced standard place. But it'll dump that if it has it. Module versions, again, this actually, it's not useful a lot, but when you do find yourself using it, you're like, damn, it's glad I had that there. You can very quickly see what versions of modules were loaded. Memory usage, this actually shells out. I copied the Plack Middleware Debug memory module. It's potentially eating its own memory, making its own memory, but I don't know. So patch is welcome if anyone wants to fix that. And then warnings. So you can see the one right there. I don't know, can you see that? Does it just look really weird for me? And that was counting those warnings, okay? And we've got the yellow here, and I'm just going to show you real quick if I can find this window. The code for warnings. I know this is probably wrong, and I know this is almost certainly wrong down here, but again, patch is welcome. But highlight on warnings. So we were passing the notifications that get used in the UI. We can also pass just random metadata. And it's random in the sense that we don't actually enforce the set of keys that are used because we don't care. You can pass whatever you want. It's not random on the other side because the other side the UI only understands a few different things. But one of the things that we do understand is highlight on warnings. And that basically means if there's a notification that indicated that a warning happened during this request, and this debug panel is active, we're going to highlight it. So we're going to change it to that yellow color, and then we're going to make sure that that top thing on yellow comes out, and then everything pops out. And the idea here is, and I know I said before, I had to make this less intrusive. The fact is, you can be too less intrusive. This makes sense, but you understand what I'm saying. If a warning is happening and an error is happening, and these people don't use these debug panels, they're never going to know. It's going to get out to production, there's going to be warnings, there's going to be errors in production. Now, we monitor all this crap, so we're going to see it pretty quickly. But wouldn't it be nice if they just fixed it when they did it the first time? So we pop it out. So that's the one point where we're actively intrusive as opposed to unintrusive. So, I think there's one other one I wanted to show. No, actually no. Okay. So I've shown you different panels that come with the distribution once it gets up to CPAN. We have a handful of custom ones we wrote at Booking that are really only specific to us and our specific data needs. But it's actually very easy to write a custom panel. You don't even have to do a subclass. You can actually do it all in line right there if you were so inclined. Let me just zoom this in a little bit here. So this should look fairly similar to what I showed you before when I showed you the actual source code for the panels. But like I said, because the constructors are well behaved, you can pretty much pass in all the information you want to the constructors. So we've got a couple things here. We've got the title, just a string, I don't care. If you don't specify the title, we'll make up a title for you based on the ref adder call. So like it's just basically Plack debug and then a bunch of numbers, not very useful, so I suggest setting a title. Formatters, which I mentioned that I talked about before. So what formatters are just another form of metadata. And what they basically do is tell the JavaScript UI how to format this. And it's just as simple as this. We have a formatters hash on the JavaScript side that has entries like this in it. And it's got two things. It's got a callback and it's got the formatter itself. The formatter gets the data, writes it out into HTML, does all the DOM stuff it wants to do, which is pretty straightforward. The callback gives you the jQuerified DOM node, that's the E, the element, and the data. And then from there, you can basically add other features and functionality to the UI itself. That's how I got that expanding, collapsing stuff in the last thing. Next, the before callback, again, a demonstration of the notification stuff going on here. The after callback. So the before and the after. Before gets, basically we initialize the request with the debugger, run all the before things, then we actually call the actual app that we're wrapping with the middleware, and then we use the response CB, response callback, which is a feature of Plack middleware that allows you to not worry about whether this is a streaming response or whether this is just a file handle or what. It doesn't matter what kind of response it is, the response callback will just do the right thing. And make sure that you can call code that happens after the response is done. So the after, make sure to call in with the, the response callback to do that. So this notifies, hey, an error happened. Obviously nothing really did, but this is just demonstration. And then it sets the result. Here we're just passing in some structured data. You can pass in HTML. We have some of the older panels that we had with the old Plack middleware debugger at Booking that were just all this crazy HTML and stuff like that, and I didn't bother trying to port those. I just stuffed the HTML down the wire. Or rather, stuffed it into the JSON later on. But you can put structured data in here, you can put HTML, you can put whatever you want. It doesn't matter. The result does not care. One important thing to note is on the way out of the request, we reset all the panels and we aggressively delete anything that you put into result so that we can basically, we can't guarantee there's no memory leaks, but we can certainly guarantee that we're not the cause of it. Then the metadata that I talked about before, we had the highlight on warnings. There's also a highlight on error, and you'll see what that does in a second. Warnings. And then again, this part is always pretty much the same. It's the setting up of the debugger that you get a lot of your features into. So this one, again, jumped out. Why? Because we had the highlight on warnings and highlight on errors. But it's red this time because there was an error, because errors trump warnings. Okay? And this is pretty simple. You get your, but when you have a panel that also errors and warnings, you're going to get the count, the 1 and the 2, or the 1 and the 1 there. This is going to show, and then this is our nested data callback, which we saw before, and it just displays there. It'll close everything. But so, very simple to write your own custom panels just in line, just get it quick. You don't feel like you need to do anything more than that. Say maybe you just have a specific problem for like this week and you don't need to commit the code or anything. You can very quickly throw together. Okay, so custom panels. Right. 2 more examples and then we can do questions. AJAX support. This was the original reason why we did this in the first place. Now the Plack middleware debug AJAX, it worked. It's not that it didn't. It didn't work for our specific needs. We actually needed all of our data to be loaded through AJAX. And we were actually doing that even in the old version, which was part of that whole spaghetti picture that I showed before. But AJAX support is actually pretty much as simple as this. Just putting in the AJAX thing in there, and why that does anything interesting is, how do I lose my paper? All right, never mind, forget it. I'm not going to bother because I don't really want to just sit here and watch it crash. So all it is an extra piece of metadata. Thank you. So here, you guys can see. Woohoo! Blind text died. Better than other things done. So all the AJAX thing does is actually just pass the piece of metadata that says track AJAX, okay? And it tells the JavaScript UI side, all right, now you need to start tracking AJAX. And what that means to that is it needs to inject, well, it uses the built-in jQuery global AJAX handlers. Eventually we'll port that, but it basically registers with jQuery and says, every time you send AJAX, I want to know about it.
Cool. And
every time it completes, I want to know about it. So it registers these 2 handlers so that we can do things and we can begin tracking all that stuff. And the purpose of that is that, you know, it's one thing to be able to see the information that you have in your particular request, in the lifetime of your request. But that's not how the web works anymore. Like, it's not just one request and we're done. most of the time that request is making a bunch of sub-requests, a bunch of little AJAX requests off to the side. So, let's see. So, when we do that, here's a little example. We've got an AJAX panel. Nothing too interesting going on here. These two little buttons will fire off some AJAX. Sorry. Test me. Hey, look, that updated. Okay, so that AJAX request fired in the background. It actually recorded all this debugging data, and then it told us, hey, we captured data for that server request. You want to see it? Sure, great, cool. Now we can see it. This little bit is actually just stuff that we capture anyway. Just the method, the UID of the page, the timestamp, stuff like that. But each of these sub-requests actually will have their own set of panels on them. Unfortunately, the only panel that we have is the AJAX request panel, which doesn't make sense to be in an AJAX request, so we explicitly disable it. So you got nothing here. So there's nothing to see. Which is why you usually want to use it with some other panel. And here you can start to see more stuff. So we Plack response. We're enabling Plack response. Actually, no, we should put it in both panels. So it makes sense to do too. So I enable two panels. Warnings, so I'm capturing any warnings that happen in the request, and the Plack response. The reason I enable the Plack response is that little green dot there, because it's checking success or error in the request, okay? And like I said before, it will take the sensible subset of panels and run them and capture that data for the AJAX request. So, I just ran that test meet, which happens to throw a warning. Now there's no warnings on my current base page, but there was a warning on my AJAX request. And these are the insidious ones. These are the insidious little warnings that can very easily get lost. Because you go to that page, 5 little AJAX requests happen to like populate some drop downs or some sort of crazy stuff. And you didn't realize that like you just dumped 15 warnings in your error log, because when you go back to look, maybe you're just looking at the current request that you have there. So they're very easy to sort of get lost and slip away. So what the hell? Okay, yeah, it's too squishy. But so you can see now here we've got more interesting stuff. Now we're capturing data for each one of those sub-requests, and we've got the Plack response information, which was our little JSON, and then we happen to send a little helpful warning saying, hey, we're sending this down the wire. Now, also, we can break it. Now, this is an AJAX response that died, that threw a 500. And you can see that because, well, first of all, it's got a little red one there saying there's been an error. It's certainly not succeeded. And it also happened to have a warning. Now, if we open this up, see 500, we can see the warnings, all that stuff like that. So it's hard associating that initial request with all the sub-requests. And it's not just doing it in sort of a loose, implicit way. Actually, the way it's structured, when it goes down into the storage on disk, it actually stores the sub-request into a subdirectory. And each one of those JSON files that contains all that information actually has a pointer to say, well, our parent request is that. Okay? You remember before I broke apart all the pieces. If you were actually, say you're debugging, you want to debug your JSON API. Well, I can't inject JavaScript into your JSON responses. That's not going to be useful, because it's just going to be a long string that's going to cause all your JavaScript parsing or JSON parsing to fail. But maybe I want to debug that stuff. If I put the collector in there, I'm still going to collect all that information on the server. And I can go look at it in some other way. I can write a script to go over it. I can do some giant MapReduce job. I can do whatever I want to look over all that debugging data, because it's been written down to the server form. But of course, if it's an AJAX thing, we can do that there. Okay, and I think I'm running almost out of time, so I'm going to be quick. Just real quick, data format. It's JSON. Like I said, we use JSON is sort of the default that I was using in the tests, but JSON is only enforced on the web API, because we need to talk JavaScript. but the this could be serial, this could be data number, this could be whatever you want. But this is basically the set of keys. We start with the URI and when it was called, the method, the timestamp when it was, the request UID, which by default is that timestamp plus a sequence. You see the title. Some of these things should be familiar by now. The notification, the counter on the success and the error there. We got the results. We got the metadata that we're passing in. So all this stuff is in there. Again, think about the fact that you can go through that debugging data, do some aggregate analysis on it if you want. Say you wanted to, say we're doing like like testing, UX testing, okay? And you wanted to be able to, you set up a server for each UX tester, and you want to record every action that they do and every interaction that they have with it. You can just enable the collector middleware, and it's going to get written to the temp directory on that server, all their requests. You can go back over it, you can analyze it with a script, do whatever you want. So that the decoupling there allows this debugging information to actually be used in a number of different contexts. I'm going to show a quick debugging the debugger, because this is kind of a fun slide, or a fun example. How many of you know what a chaos monkey is? Okay. So, let's see which one to okay. So one of the really so the cleanup phase of a PSGI request, there's very few servers that actually support this, and what it is, it's an asynchronous phase. It happens after the request has been flushed. The server then calls back. If anybody's done old mod Perl programming, use the Perl cleanup handler phase in mod Perl. This is basically that in PSGI. Okay, so that's actually, when possible, that's where we actually write our information. One of the problems that we had at Booking was we were writing so much information. We were writing in the cleanup phase, and it would take a while for that to actually get written and get down to disk and everything like that, so that by the time the page actually loaded and then it tried to call the debugging information, it wasn't there yet. And so one of the other complaints that I was getting a lot of, I'm getting a lot of errors, can't load debugging data. Well, that's just because your KVM's slow, you fucked something up. But that excuse only lasted for a while, so I had to fix that. And to fix that, I put in the chaos monkey. So let's see if the chaos monkey is going to strike. Yes, it did. So it's got an incremental backup. It tries, it fails. Okay, well, all right, well, I'm going to give you a little bit of time. Maybe you haven't written all your debugging data yet. Tries, fails, tries, fails. But it does this with longer increments at the end, and then it's going to die and say, hey, it wouldn't work. Let's see how far it gets this time. And you can set this. So if you're having a bit of trouble in your environment, like I'm having here, you can set this. There's a chaos monkey tolerance that you can set in the environment. Test that. Yeah, so it's never going to succeed. I guess set tolerance too low. All right, real quick. I have extra slides. Future plans. We're already in the process of dog fooding this at Booking. Actually, I released it first as an optional thing, and then on like Friday at like 6 o'clock, Ivar, if anybody knows Ivar, they'll know this antic. He decided, no, it should be default for everybody. So on Friday he did that, and then I was gone for like Monday and Tuesday. So I came in on Monday and Tuesday with a whole bunch of complaints. Hey, I heard this Plack Debugger was your fault. It's causing this, it's causing that. And then Ivar went on vacation when I got back, so I didn't get a chance to get after it. But we are using this, well, everybody's using it, so all 600 devs. Half of them may be ignoring it, but that's fine. But we're using it pretty extensively, and already it's been the subject of a couple little hackathons that I've done there to sort of improve it. With the last bit of improvement, I actually tried to make it really lazy, so it only loads. It'll do that first request to get that debugging data, but it doesn't actually render anything in the DOM. It just waits until you actually open up the panel. So if you don't open up that debug panel, it doesn't mess with your DOM or anything like that. And I'm going to try and make it even lazier after this. More information visualization, because we love that there at Booking, and it's also just kind of really cool. We use jQuery, and here's the kind of annoying bit about it, is that you can only use the jQuery that's already been loaded. You can't basically reload another jQuery. Some of the later versions of jQuery support this a little bit, but not enough that I was able to control it. So I'm stuck actually supporting whatever version of jQuery happens to be there.
Which is basically all of them.
Right. There was somebody said something the other day that I think it was a commit with more than 3 JavaScript files in the booking code base almost certainly will also include a version of jQuery. So, and there are a ton of them in the code base. Some really old, some really new. So actually a lot of the pain of writing this was actually going and testing it and realizing that I had to support jQuery 1.2 and 1.4 and 1.7 and all that stuff like that. So I ended up writing a lot more JavaScript. Consequently, we're going to try and get rid of jQuery. One of the front-end devs at Booking tried to convert it to React.js, which is the Facebook sort of DOM manipulation thing. 'Cause mostly, once I wasn't able to use any new features of jQuery, it basically came down to DOM manipulation, and everything else I had to rewrite itself. So it should be relatively easy to port it to that, which hopefully we'll do soon. And that's the end. Questions that I'm probably out of time.
Oh, you're good for questions.
Oh, good for questions. Okay. Questions?
You coupled the injectors of the draft. Middleware Debug discussed means to clean up after yourself when things stores the data that exists in the request. I assume it's also developers stuff like that.
You mean the files that are written to temp?
Yeah, so if
Yeah.
request anything, that's not
So
Can you repeat the question, Steven?
Yeah, sure. So he was basically saying, hey, you're writing all those files to temp, but you're not cleaning them up, which is absolutely correct. I tried to come up with the same cleanup strategy, and there really wasn't any one specific one that would apply to everybody. So in the booking code, I forget exactly where I have it. It's in somewhere, either way. But it goes through it. Basically, it looks through the modification times on all the files. If it was more than a day old, it throws it out. If it figures out it was yesterday, you don't need it. So and that really is a pretty quick, like, glob over all the files in there, and then just delete. So I'll probably actually put some docs about that in there. But yeah, it's up to you how often you want to clean up. So, but yeah, because it's just a lifetime request, but because it potentially is valuable as aggregate data later on.
Also, a lot of stuff like that in our dev environments automatically cleaned up every night. We have hundreds and hundreds and hundreds of KVMs. So if everybody had like huge log files and stuff, then we just run out of space. So we just unilaterally every night nuke all their logs, nuke all their templates, nuke various meta stuff, so that the next morning they have to recreate it.
Every morning I come in and the tail of the error log says, oops, truncated.
Yeah.
So we do clean that stuff up.
The stored data you collected, is there any benefit in thinking of replaying that verification?
Yeah, so I thought about that, and I was actually thinking I would write some scripts to show like a demo in here, but I didn't get around to it. But yeah, I mean, there's I don't know if you're not. Well, you have all the Plack response and request information. Put it in there. You can potentially write your own debug panel that actually pulls the full HTTP request if you didn't want to necessarily just leave the Plack stuff. But yeah, you could use it to replay data. That was the point of sort of the idea of the UX. If you want your testers to do that, to be able to really look at, because it's timestamped, so you can see the sequence of events, you can see what happened when, and all the interactions. So yeah, there's a lot. That was a lot of why I wanted to break those things apart.
So does that mean if a tester comes to you and said, "Oh, I was playing around with the website, I don't remember exactly what happened, but then it crashed,"
Yeah.
you can.
If you've got the collector written on there, then you don't have to be like, why do you never remember? You can skip that whole part and just go in the logs and fun.
So this isn't really about this, but it's probably about something you can answer because of this. Back when Plack was new and cool, there were a couple of talks, and in the same talk, this was shown, the debug middleware, at the same time as the REPL on error and the browser thing, which everyone thought was really cool. And then about a year later, I was like, hey, anyone using that? And everyone was like, no. I was like, why? I went looking for it, didn't work anymore. Have you looked at that as well?
So, one of the things we do at Booking is we grow Perl developers. Meaning, like, with the group of people that I came in with, and the ones that were sitting next to me, there was a C++ or C# developer, there was a C developer, there was a PHP developer. I was the only Perl guy in that group that came in. The PHP guy wanted to be able to refresh the page really fast and not have to restart the server. The C# guy wanted everything to compile in the background when he was making changes, so he could just refresh the page and see that information. C# and .NET. And the C guy actually wanted to be able to connect his IDE debugger because he was so used to writing desktop apps in C, where you get all that nice stuff there. So yes, the roundabout way of answering this is yes, we are looking into doing stuff like that because there's a lot of people who really would like some sort of back and forth.
That's kind of the thing, is you've got REPL in the back.
It's entirely possible, yeah. So, and I don't think I'm giving them any confidential information, but actually right before I think, yeah, it was last night. I don't know if you saw this, Eve. One of the other guys at work has been fiddling around with the back end of the Komodo debugger, which can talk over the wire from a web server. I think they have this set up for like the Python stuff and things like that. He committed, and it's very experimental, but he just committed a thing to basically a Plack middleware that does that enables that. So you can take the IDE and you can connect it into the debugger of the actual running process at the time. Set breakpoints in the code, all that kind of fun stuff like that. So in theory, and he sits right next to me too. So at some point we're gonna combine this. But yeah, in theory, a REPL we'd like to have some sort of breakpoint debugging type of stuff there if possible. But the part of the whole purpose of not just injecting a bunch of HTML, but injecting sort of an active component, meaning the JavaScript UI, was that we'd be able to enable that kind of behavior, the bidirectional communication, which the AJAX one actually does that. So it's just a matter of expanding it going forward.
Last question, please.
You gave an example of one storage mechanism, which is file. We ran running one service. Subsequent AJAX requests.
Sure.
And fetching data with the same website.
So the API for the storage component is just like load results for request. You pass in the request ID. Load all sub-requests for requests. You pass in the request. So it's a very simple API. You can write it, and your storage can be wherever you want. The one that I have, yeah, is just files, but as long as you conform to the API, put it in a database, put it in a memcache, put it